But for now, I want to welcome Ida to the stage, Grafana Labs. She'll talk about how to refactor your code. Have fun, good luck.
Hi everyone. So as the title of this talk suggests, I will talk about storage and the recent storage problem that we encountered at Grafana. I don't know if you're familiar with Grafana. Okay, cool. Oh yeah, so I will tell the story of how we solved our storage problem, or we made our storage a little bit better, and the story of the refactor. So first, a little bit about me. So that's me on vacation in my happy place. I'm a software engineer at Grafana. I'm at the backend platform team, trying to make the code base cleaner and better for other people to make it easier to contribute. I'm also, our team and myself, we are trying to enable other teams to build features on top of our platform. These are some of my hobbies and things that bring me joy, so if you find there's something to talk about, we can do it after my talk. So let's start. So my talk will consist of 3 parts. So first I start with the history of Grafana, like how did we got to the point that we had to refactor. I call it the snowball effect. And then the other part of my talk will more focus on the actual definition of the problem and our solution. The last and most important part will be the story of the refactor, how we proceeded, what setbacks did we encounter on our way, and actually if we succeeded, and how happy we become after the refactor. So a little bit of the history of Grafana. Grafana backend code is around over 7 years old. Grafana has been a very successful product, so there was more focus on building new features, and it wasn't that much focus on keeping the code base clean and refactored. So that's definitely something that people put much more emphasis on the new features. So Grafana version 1. Here is the database engine that we used in version 1. As you can see on this slide, there was none. So in version 1, no database engine. On version 2, please keep in mind, so this, our backend, version 2 was the first version that the backend was written in Go. At that time, Go was a pretty new language. Not many people knew Go best practices, so our engineering team chose to use global variables for our database engine and for our storage solution. Oops. I don't know. Oop, okay, it's back, cool. That's not my slide at all. Okay. Okay. So version 2, global variables. And I don't know what's wrong. Sorry? Show anyway, okay. Okay, cool. So version 2, this is our storage function, the get dashboard. The only important part, I would say, is the get dashboard. So we use the global variable, we return the dashboard. As you can see, a little bit strange, in the function signature, we are not returning the dashboard. But that brings me to my next slide. So most of our engineers, they were .NET C# developers, and they used the best practices coming from their languages. That's why they decided to introduce the bus abstractions. So basically what they did, they just registered the functions and used the dispatch to call the functions from our get dashboard API function. So yeah, so this is how we were, what was the code base like back then. Fast forward to Grafana 6, not that much has changed, but there has been a shift from global variables to the struct. It's kind of like a Go object, so to say. And we used the SQL star struct for our storage, which can hint that we try to migrate away from the bus framework and functions and use in this version, we already had some methods that were actually returning, it's not very visible on my slide, the data structure and avoiding the bus abstraction. In my talk, I'm not going to talk about the bus refactor. I will ignore it, but it just adds complexity to the storage problem. So here, when my team comes in and our efforts, we know it's version 8.4. We already know storage is unmaintainable. It's not flexible. We need to come up with something better. We cannot have the whole storage defined on a layer on this single struct. So we defined the problem. I'm spoiling a little bit because at this point we didn't know that it's 140 methods on the SQL store. But we knew it's big. Then we knew there are some bus leftovers, some other storage functions that also need to be encountered into our refactor. We didn't have any overview, readability, and we had no flexibility. If we would, for instance, like to add a different kind of storage, a file storage for a feature, it had been really difficult to start and it would make things even more complex. So we had our goals. We knew what we want to do. We want to break down the huge storage, and we want to enable partial refactorings. Also, Grafana is a growing company with many teams that own features, and we wanted to allow teams to own their features from the API to tell the storage. And we want to competitive storage per feature. That was our goal. That brings us, so how do we start? Interfaces. Is anyone not familiar with the term interface? So in Go, it's basically just a collection of method signatures, but if that doesn't say much, imagine an outline of the book. So we were brave to define an interface, our storage by an interface. So we still have the same SQL store struct, still all the methods are implemented on the single object, but we defined an interface with over 140 methods. A huge, gigantic interface. Please don't do this at home. Even while writing or adding this code, we knew we don't want to have this. We want to get rid of it. And that influenced our design. So we decided to design per feature and per table. So we defined a service and a store layer. So the service layer will be defined also by an interface, a much smaller interface, only per feature. It will be called from the API, and it would include logic, some validation, cross-service calls, observability, calculations, and so on. The storage layer would be very simple, also defined by an interface, but the methods would be CRUD-like, create, read, update, delete, or list. So very simple storage, and it will be only called from its own service. So this would make it this design allows us to add other types of storages easily. Okay. So as our POC, proof of concept, we just chose a very simple service, preference service. If you're a Grafana user, UI team, time zone, and so on, those are the preferences. This service had only 5 methods. We decided to move the data models, the data structures to the service to avoid import cycles that are quite common for Go developers, I would say. We know them very well. We decided to test the service in other services with fakes. So that was our design decision. How does service look like? So the implementation of the service was holding the store, and the simple method get with defaults, it returns preferences with their defaults. What's important here is that it calls the store method list, which gives back a list of preferences, and there's some additional service calls, some JSON data, getting defaults or the ones coming from the list, and that's it. So this is the get with default. On the store side, also a simple interface with only the CRUD methods and list. The SQL store implementation holds the database connector, and this method just goes into the database, uses the database engine, and returns a list of preferences. A more simpler solution, if you look at the bottom function, the only important part, that's the store function returns a preference. The top part doesn't do actually anything. It only wraps, it's a wrapper around the store function, and the only thing that it does, it exposes the store interface for the rest of the code base, the API or other parts of the code where it's needed, because the store is, as I mentioned, it's private. Okay, so now the juicy part. We are starting with the refactor. We have this large monolithic code base. How do we start? How do we start with our refactor? We knew we have over 30 services. Some of them go up to 18 methods, and some stores query multiple tables. We knew that we are splitting up the huge interface into by feature. So we were thinking, okay, let's go store by store, service by service, and let's implement this. So our original scope was this one. So we knew the size is 30 services, and let's add store methods and service methods to the service and the store. Let's make the store method private, make them CRUD-like. Services call other services, that's fine. As a next, so this is basically the first part is just adding all the new code. The second part, let's use everything that we added in the API and in our enterprise edition. And the last step would be the most rewarding one, removing code, deleting the actual methods and also the methods from the interface. How do you think this went? Any guesses? I wish we looked at it and discovered it more, and we would have maybe saved a few weeks. It was just too much. We didn't manage. We had no sense of accomplishment, just a frustrated bunch of engineers trying to, do other stuff and not this. So we knew we had to go back and refactor again the scope. So we were adjusting the scope round 2. So we tried a one method approach, just to take a single store method and try to add it to the service part and the store part with the same rules. Private store, CRUD store methods, implementing it in the API, in the enterprise, and then removing. That seemed more feasible, but I came across the user store service part of our code base, which is basically kind of like an HR of Grafana. If you log in, you have a user, you can be admin, editor, and so on. So this is a very simplified create user method, and what's important here, it creates 2 different tables. It inserts a user and an org user, which are 2 separate tables, and it does it in a database transaction, which we did not consider in our POC. This method is called throughout the code base over 100 times, and I'm not even counting the enterprise edition. And another juicy method, delete user. This one, I think I left out 1 table, but it creates 10 tables, also in a database transaction, and it's called only 10 times throughout the code base. So these are all the challenges that only 2 methods caused. And that would be, what do we do with the database transaction? Our model is not suitable with those. Called approximately 100 times per code base, how big the PR is going to be. Throughout the code base 100 times, how many broken tests? How do we actually test the code base when somewhere in the API we have still real database tests in our testing framework, and now we want to use fakes? Import cycles. So for instance, just the database transaction, it took cross-functional efforts and architectural decisions. How do we approach this problem? And also some of the decisions were made uniquely for the case. We said sometimes it's okay to have orphaned records, and sometimes we need to clean up after ourselves. So that took too long, and on a monolith you can imagine the havoc of the merge conflicts that were created. So it brought us back to come again to square one and refactor the scope. So we decided to do the scope not granularly, but in layers. So we would have the first iteration, which would be simply adding a single service method to the service. This service, we would inject a SQL store into our original old SQL store that we wanted to get rid of into this service, and we would just write a wrapper, the service method wrapper around the original SQL store method. Bear with me, I will show an illustration. And the next step, we would use this new service and call it from our API and the enterprise edition. So this is what actually happened. First, so before the step 1, API calls directly the SQL store, and now we just injected an extra layer between the API and SQL store. So this step iteration may seem extremely simple, but it actually brought success. We were able to implement it throughout the whole code base. And made us a little bit happier. So first success since the beginning of the refactor. The second step of the round 3 of the refactor, we decided to copy everything we have in the one store, the one blob of the store, and copy it into the belonging features, where we would remove the wrapper around the old store, and we would just from the service call the store's methods, but not refactored, just as they were in the old place. And still, the store is private, so it needs to be exposed by the service interface. This time, we are allowed to delete the SQL store and delete the methods. So this is the illustration. So before the step, after the step 1, API calls service and the old store that we want to kill. And the second part, after the step 2, API calls the service and that calls the store. So this went also very well. We were actually able to do it on most of the code base, happy engineers, so this was a success. But I have their final result with the quotation marks. So I'm pretty sure no one remembers, but in our POC we had other things, which I'm very passionate about, to refactoring store methods to CRUD and moving all the logic to service level. I'm passionate about that because that would make it so clean to add other types of storages. In-memory tests, that would be great to have. Wrote how to use the solution, maybe a default one that would fit most of our use cases. How do we build the database? How do we deal with the database transactions? Then figure out the dependencies between services. These are all the to-dos that we still have. But my personal learning throughout this process, where I was copying over code and moving it around and felt like I'm not doing any impact, I actually noticed that there's an impact in copying over and moving around code. And that's our results. Right now, we have separated services that can be further refactored. And on the monolith, that's something amazing because it just makes it so much easier to work with other teams on the same code base. Also, we have a separated list of to-dos, and now some services can be, or some stores can be owned by other teams, and not my team has to deal with this anymore. So that's all amazing. It is better. We are happier. We like to open the code base much. It's a much more pleasure to open the code base. We hope also anyone contributing to the OSS repo feels the same way. And it's not perfect, but it's good enough. And yeah, thank you for your attention. Oh.
Did we lose our host? Cool. I'm your host now.
Cool.
Let's see if there's any questions. I'm also in charge of the questions, so that's convenient. First question that I'm going to improve. There you go. They're coming up. What was the motivation for this refactoring?
It was just too big and not flexible. It came to the point that we just had to do it, and we thought if we build more features and it will be even larger the scale, it would make it even harder. So I think after 6-7 years of building a backend, it was time. So definitely time.
Perfect. Second one, how many people were involved in this refactoring?
You mean after which setback? At the very beginning, it was more people, most of my team, but I think after each setback, more engineers were turned off. So I would say in the heydays, it was like 5 days, and sometimes it was 2 people.
Right. Any more questions? Otherwise, we're continuing with the schedule. Thank you so much for your talk.
Thank you.
We have a little gift for you.